All right, so we're looking at a new type of question, something that you haven't seen in forever. Well, not really. It's a probability, it's a proportions problem without a single probability given. Said, so during a recent movie production, Fruito's cereal placed many action figures in some of its boxes. The advertisements on the box states that one out of every four contain an action figure. So one out of every four, or 1/4, or 0.25. So that's my p hat. That's a proportion of the population. It's a parameter. So Q then is 0.75. So a group of promotional toy collectors suspects the proportion of boxes containing the action figure may be lower than 0.25. So they purchased 70 boxes, and we're going to assume the 70 boxes represent a random sample. And they found 12 action figures. So X is 12, N is 70 boxes. Uh-oh, come on, pen. This is 12 boxes that contain the figure. So that gives me p hat is 0.17, or X 12 divided by 70 is 1.1715 or something. I just made it 0.17. That makes Q hat 0.83. Okay, so assuming that it's a random sample, is there statistical evidence that supports your answer? The toy collectors believe the proportion of fake boxes containing the figure is less than 0.25. So we're doing a hypothesis test. And so alpha is going to be 0.05. My null hypothesis is p equals 0.25. My alternative is p is less than 0.25. And I'll talk about the standard error here in a moment. So let's look at our conditions. Assuming the 70 boxes represent a random sample, because that was given to us up there. 70 is less than 10% of all boxes of cereal, whether this company or any company. So I find NP, not P hat, but NP, because we are given the parameter. So 70 times 0.25 is 17.5 boxes, which is greater than or equal to 10. NQ then is 52.5, which is greater than or equal to 10. So we can run a one proportion Z test. We're going to run a one proportion Z test. So I'm going to go stat, go over to test, turn off that light, and I'm going to run a one proportion Z test, which is number 5. So I put my null hypothesis, we put, well, it is the null hypothesis, but our parameter is 0.25. X was 12, N was 70, and it says, it says less than. So we need to make sure we make that less than, not less, greater than or equal to. Not equal to. And then we're going to calculate. So I press calculate. I get Z, my Z score to run a Z test is negative 1.518 dot dot dot. My P is 0.064 for an N of 70, and P hat, of course, was point that. So looking at those values, we then say, okay, here's my Z. My Z, to find my Z score, it's P hat minus P over the standard error. That's the reason why I wrote the standard error there, negative 1.58. So P is less than 0.25. That's my alternative hypothesis, that my true proportion is less than 0.25 equals Z is less than a negative 1.58 is 0.06. Okay, 0.06, which compared to alpha 0.05 means it's greater than. So here's my conclusion. With such a high p-value compared to alpha, ugly alpha there, sorry, we failed to reject the null hypothesis. There's not enough evidence to support the toy collector's belief that the proportion of boxes containing the figure is less than 0.25. I just regurgitated my statement up here. Okay, the question of fact, which turns out not to be fact. Okay, so that's when given decimals, when given numbers and no statistics, no data, it's a Z test. They were talking about percentages, what's the proportion, and it says it multiple times in the problem, proportion. Okay, so we want to make sure that that's where proportions are z-test. Okay, I hope that makes sense to you, and I hope you have a great rest of the day.